we are going to talk about AtomVM, as we said. Before starting with that, I will introduce myself because I want to tell you about my background because it explains some few stuff. So, I mean, I've been a long time hardware embedded developer. I always loved working on open source projects. So, what I'm going to talk today is like a combination of the two things. Also, I like to mention that we work also at our company with Elixir, and I started with it in 2017, and since the first day, we fell in love with it. So we wanted to use it for our main product, and we are pretty proud of our choice. And yeah, last thing about me, I love hiking. And so, first question, what's AtomVM? And yeah, good question. So before starting with this, I would like to take a time machine and to get back in time. So we get back like 15 years ago or even more to the first Arduino time. And Arduino is this kind of interesting project because it's somehow the practical father of physical computing. And physical computing means that it's not just it changed the paradigm. You don't write code for displaying stuff on a screen or to interact with a keyboard. It is all about interacting with the real world. And Arduino is very interesting because it was kind of cheap. I mean, for the time it was super cheap. And also, it is super simple to assemble some kind of project. It has a reasonable IDE. It's pretty, there are plenty of tutorials, and still, even if it is a very limited hardware platform, it turned out to be very powerful. And so if we look about the anatomy of how works Arduino, well, we realize that it is indeed very limited, but still, well, just let me say that what is an MCU, by the way. An MCU is, well, stands for microcontroller unit. It is basically a computer on a chip. So you have all the usual resources you need to do actual computing on a very tiny chip. So in the case of Arduino, you have a few kilobytes of RAM, a few kilobytes of storage, and yeah, you have those things called GPIOs that they allow you to connect to sensor, any kind of device, yeah, using, electronic circuits. So the interesting thing about GPIOs is that they can be configured in a certain way at runtime. So you can do a lot of stuff. You can have a lot of different configurations. And luckily, things evolved a lot. So Arduino, by default, didn't have any kind of internet connection, even because there are no resources for doing that, so you did need some other solution. And things got better. And years later, we started to have stuff like ESP32, that the entire dev board was even cheaper. But more interestingly, there are more and more resources compared to Arduino. So you have 2 cores, you have more RAM, so you can handle network connection, even with TLS, so you can do it in a safe way. And there is plenty of flash, well, 4 megabits or even more, but yeah. And yeah, as I mentioned, the most interesting thing here, there are a lot of connectivity options that are built in. And also they improved all the GPIO stuff. And still, this solution can run on battery. It can be very, very low power. And if we take a look to how is the schematic, we can notice that there are a number of different options. So you can connect any kind of sensor or peripheral you have in your mind. That makes this a very interesting solution for building objects. So any kind of object you can think of. And of course, there are other solutions that are interesting. and there is around also the Raspberry Pi Pico. That is a pretty similar solution. And the main difference here is that usually you don't even have a default RTOS. So there is no operating system. You have basically an SDK that you can use. It is interesting also because it has very advanced programmable I/O options. And yes, they are both interesting solution for building any kind of stuff. And so the point here is that those devices are very cool. They got better, but still we are far away from a standard computer. I mean, as I mentioned, there is no operating system. The RAM is still in the order of megabytes when we are lucky, but still, another point is that most of the development happens in C or C++. That is kind of tricky because, as I mentioned before, for example, the ESP32 is a dual-core device. So we can actually do concurrent stuff. But, you know, concurrency in C can be tricky, can be hard to get it right, and etc. And if we think about handling network packets, we do binary parsing for protocols. But parsing binaries in C, in the best situation, is just boring, but it can be dangerous because you can get security issues. And yeah, then you need to connect maybe with HTTPS to some kind of remote service. So maybe you have to call several endpoints. So you need async stuff. But as soon as you do async stuff in C language, you get into a callback hell. And that is very, very annoying. And let's not even talk about memory. Because when you don't even have a real operating system, there is very limited memory protection. So in the best case, you get some kind of reboot because you crash. But you can have also some corruption that is not nice at all. And yeah, you have also to remember to free memory, because if you don't do that, you run into memory leaks. So you working with this C on those network-connected devices, it is very painful. Also, I would like to give you another example. This is something completely different. This is a very popular project, so if you do hiking or other sports, you can use it to have some long-range radio communication with your friend. You can send a message. So this kind of project has all the stuff like routing, mesh network, and also all communication are encrypted. So this project used C++ to get this done. And if you look at the source code, I can assure you it is very complicated. It is very complicated because all those stuff in C++ don't feel natural. I mean, you can have some abstraction, but still it is hard. And yeah, but if we think about what we have here, if we think about Elixir, all that stuff turned to be very simple. It turned to be very clear. So what in C++ is like 10,000 lines of code here gets like just one slide. And you can have all the parsing stuff in very few lines. So this is amazing. But if we think about the beam, we cannot run the beam on those small devices because the beam is not, right now the beam is not designed to run on low memory devices. So it's pretty sad because we would wish to have it. So my question here is, what if somehow we can use it anyway, Elixir on those devices? What we can do? To answer to this question, I created AtomVM in 2017. And AtomVM is an implementation of the whole virtual machine written from scratch. I did write it from scratch because I had to go with different trade-offs because those devices have different priorities. So I had to take care of memory. I had to take care of portability. So it's a kind of different solution that have different priorities. And yeah, so let's get back to the previous example, but I would like to remark this is just an example. I did the same kind of firmware in Elixir that is compatible with the other, and it turned to be very simple because all the mesh, all the LoRa radio handling was super straightforward with Elixir. And I would like to say that even the interface feels more reactive in Elixir because we get the concurrency in a very easy way. So it's very easy to react to user inputs. So it turned to be like an interesting approach. And also there are other different devices that, well, very different devices that can be made with AtomVM. This is kind of a useless box. It is a very funny device. I suggest you to take a look to this. The interesting thing here is that they use Erlang here in an even more less powerful device, but still they can do process audio pipelines and they can play sounds and whatever. And also this kind of device consumes a very, very low amount of power when in deep sleep. So it's super cool. And what I want to say here is that with AtomVM, we unlock thousands of different possibilities to interact with the physical world. So we are bringing Elixir and the whole ecosystem to something very new, something very different to what we have been used to. So when we talk about physical computing, we start always with something very simple. That is the kind of hello word for the physical computing, that is blinking a LED. Maybe some of you know how to do that with Arduino. And if we do that in Elixir, it's pretty obvious. It's pretty simple. And so that's the code, just a few lines. And yeah, also with AtomVM, we have a very simple to use library that you can add to your mix-AXS, and you just work as usual, mostly. You just have an additional command for writing the software to your device, and it works. And yeah, what I want to remark here anyway about also the whole process is that we are running unmodified BIM files. Well, mostly unmodified BIM files. We are not transpiling. We are not using any kind of weird trick. Everything is pretty regular here. We just did a different implementation of the virtual machine. So same bytecode. And yeah, I'd like to mention very briefly Nerves. Nerves is an awesome project, but there is just a big difference here, is that we aim to two different targets. Here we aim to targets that have very, very constrained resources, while Nerves is more about Raspberry Pi devices and several other devices, but they are way more powerful. And yeah, of course there are some caveats because yeah, we had to introduce some limitations. And yeah, some modules are missing, some functions are missing because, well, the flash memory is pretty limited. So if you look for dgraph module, you will not find it. So you need to find some kind of solution. The good thing is that our tooling helps you finding helps you to find when you use something that is not supported. So as soon as you try to flash, if you use something that is not supported, you get an error. So you can iterate over in a very, very fast way. And yeah, I would like to also to mention, it is a very active project. So I would like to mention what we are doing now and what we are going to do in the near future. And recently, we introduced Erlang distribution. So basically, you can connect to one of those devices in the usual way you are used to, while there are other possibilities. And also, in the near future, more features are landing, like we are introducing proper big integer support, still with its own limitation, of course, for the sake of simplicity and efficiency. And yeah, also, even in the future, we are planning to do more. We are planning to support more devices, like all those devices that are Zephyr enabled. We want to support more connectivity options, so you can build more different kind of devices. But the most important thing is that we care a lot of developer experience, and we care a lot of keeping things simple and to improve your workflow. And still, we are in the 0-point-something version. We aim to 1.0 and to have some kind of stable APIs that they are not meant to change, so you can have some kind of long support. So next, I gave you a definition that was like AtomVM enables you to run Elixir application on microcontrollers. But the interesting thing is that we can rephrase this definition, and we can say that AtomVM is about running Elixir and all the other languages of the ecosystem on constrained environments. That brings us to talking about the horizons. So it's time for Mateusz.
Hello. I'm Mateusz. Thanks, Davide, for your part. So now the part about the horizons. So before I tell you what are these horizons, let me start with bringing up some context. So first, it all started when my involvement in this project, in the AtomVM and other work related, started when the company where I work, Software Mention, started a cooperation with Jose with a goal to improve the adoption of Elixir. So that's something that we all benefit, Software Mention also, because it's a software agency that works with Elixir. And we started a few projects in this framework. In particular, we started Live Debugger, which you may already heard of because it's public, and it's a debugger for live applications. But we also started another project, and that's the one I'm going to tell you about today. And this one is about running Elixir in the browser. So, wait until the end. So, from your reaction, I think you already know why it's valuable to run Elixir in the browser and how it helps adoption, but I'll mention that anyway. So let's imagine that you enter the Elixir homepage, elixir.org, and you have an IEX session running right there. So you can try Elixir, you can play with it, you can see how it works, you can fall in love with it. It's like the easiest way to get started without installing anything. We could also have examples in hex docs that are runnable, so you can just click a button and see how the code really behaves. You can play with it, experiment with it. You could have Livebook running fully in the browser without installing anything. But it's not only about the developer tooling, it's also about real production software like local first applications. So you could have a Phoenix backend running in your browser and the database synchronizing with the real backend via some local first engine. There is another keynote about local first applications, by the way, in this conference. We could also have live view running partially in the browser so that there are no requests to the backend in some cases, for example. I'm not sure if this is a good idea, but we'll see. And we could also have a full-fledged front-end framework in Elixir, because why not? And I'm sure that this list doesn't end here. The problem is that we couldn't do that until a long of time, at least not really feasibly, even though there were some impressive attempts. First of all, there was Firefly. There is Firefly, but it's not maintained as far as I know. It's about compiling Elixir to WebAssembly bytecode so that you can run it in the browser because they ship with WebAssembly runtime. And another is Elixir script, which is about transpiling Elixir into JavaScript. And you can, of course, run that in the browser. The problem is that with the Firefly's approach, you basically need to create a new compiler from scratch that compiles Elixir code to some bytecode that is not really adjusted to Elixir, not designed with Elixir in mind. So it's a very hard thing to create and maintain that. With the Elixir script approach, on the other hand, you basically need to rewrite a big portion of OTP in JavaScript and make sure that it's compatible with the original OTP version. So it's also a pretty tricky thing. So we didn't go for any of these approaches. Instead, we tried to compile an Erlang VM into WebAssembly and run that. So when you can run an Erlang VM in the browser, you can run any Elixir code in the browser pretty much. But there are problems, as if you want to run anything in the browser, there are requirements. First of all, this thing you want to run needs to be small because, well, everyone is going to need to download that on their device when loading a web page. It has to be portable so that you can even compile it to WASM and run in a very restricted environment. Also, it needs to be customizable because it probably won't run out of the box straight away. You will need to do some tweaking and customization to make that work. Fortunately, we have an Erlang VM implementation that meets these requirements, and you guessed it right, it's AtomVM. AtomVM is very small because when you compile it and gzip it, it's 190 kilobytes. So that's the size the user is going to download to run AtomVM. There's also the code that it needs to run, but it's another story. Also, it's a single binary, runs in very restricted environments. It's a small, well, it's not small and simple, that's not true. However, as for a virtual machine, it's quite understandable and you can wrap your head around it in reasonable time. And what is important, it also ships with the mechanism to compile it to WASM via mscripten, thanks to Paul, who did this and other great contributions to the AtomVM. So what we need to do is just take the AtomVM, compile it to WASM as written in the README, and run some Elixir code. Yeah? No. Because here comes the big caveat that Davide mentioned, and that's the AtomVM doesn't really run any Elixir code. Because it misses some features that the Beam has, and because of that, it cannot run the Erlang and Elixir standard library, basically. It ships with its implementation, like the minimal implementation of a standard library, but it basically means that you really have to think about these limitations when writing the code that should run on the AtomVM. So you cannot call it running any Elixir code, basically. So we stopped with our small team at Subformation and wondered, what do we actually need to have working? Because we need to run compiled Elixir code, yes. So maybe not all the code, maybe some subset of Elixir will be enough for the start. However, I also said that we'd like to have an IEX session running in the Elixir homepage. And for that, we not only need to run the compiled Elixir code, we have to actually compile the Elixir code in the browser and run it. And that's tricky because we need to run the Elixir compiler. And it's quite a big project, you know, and quite complex. and it requires a full-fledged standard library to be there. And it also depends on the Erlang compiler. It uses it under the hood, which is perhaps even bigger project written in Erlang. So we also need to run that in the browser. Well, where do we even start? There are some features missing. We are not sure which are missing. So the approach we took is fake it till you make it. So we just took the Erlang standard library, took the Elixir standard library. We tried to run some programs on it on top of AtomVM. We saw what didn't work. And if something didn't work, we tried tweaking the standard library so it doesn't use particular features that AtomVM doesn't support. And that brought us pretty far, because without any substantial changes to AtomVM, we were able to compile some simple Elixir code in the browser. However, it was only the simple Elixir code that worked, so we needed to do quite a lot of improvements to AtomVM. So most of the time working on that project, we committed to improving the AtomVM so that it supports more things and it's more compatible with the Beam. So basically, we implemented a lot of nifs and beefs. So they are the functions from the standard library in particular that are not written in Erlang or Elixir, but in C within the virtual machine. We extended support for the ones that were already there. We improved unscripted integration. We improved ETS support, because that's what compilers use a lot. We improved extracting information from Beam files, improved error handling, introduced some bugs, hopefully fix those also. We also improved the JS WASM integration. Basically, we've written a bit of API on top of AtomVM that allows you to pretty conveniently call JS from WASM and the other way. And we bundled it all up together because, as you could see, the AtomVM comes with various tools to ship, to bundle everything, to bundle the code, to flash it to a microcontroller. This is not really our use case. So we created a library that makes it easy for you to use it and to run some code in WASM. And we called it Popcorn, and it's already available, and you can try it out. So let me show you what it can do. So for that, I need to find a browser on this laptop, because my laptop didn't work on the second ElixirConf in the row. Perfect. There is Safari. Huh? Oh. Google Chrome worked. That's great. We can go to popcorn. swmention.com, and we have a nice landing and some examples. So first one is an Elixir REPL. So we can just type some Elixir and try to run it. So I checked that this works, but you know how it is. Of course, it doesn't work right now. Let's try an example. Oh, this one works. I'm sure this worked. This works again. Well, so anyway, we have a text area. We can type some Elixir. We can compile it and run it entirely in the browser. We can spawn a process, perhaps. Let it just return OK. And it returned a PID of this process. Another example we have is an Elixir docs webpage, but it's changed a little bit. Let me go to processes, because that's interesting. And this is basically the Elixir getting started guide. And it has a little change that the IEX prompt here is underlined. And that basically means you can click it and run it and spawn some processes. We can check if the process is alive, and it works too. You cannot edit it yet. However, it's a matter of making it like editable. Should work too. Not all of these examples work. That's a big disclaimer. We are not there yet, but we are close to making all the getting started guide work. At least except of the things that are not really easy to work in, to get running in WASM, like sockets or files. And the last examples I have is the game of life. Let's see if it loads. Oh, it does. Well, game of life is a cellular automata that basically is represented as a matrix of cells that are either alive or dead. And let's initiate it. And so these green cells are alive, and then I'm going to start the simulation, and in each iteration of it, it's going to change the state of the matrix. Each cell changes its state basing on the state of its neighbors. So we can do pretty interesting things on top of that. This is Turing complete, by the way, as far as I know. But the interesting part about this particular demo is that each of these cells is represented by a Gen server, and they are communicating with each other to change their and update their state. So we have supervisors, Gen servers, registry, all that working in Elixir, in WASM, in your browser. Now let me find my presentation. Okay, here it is. Well, as I said, as you could have already seen, this is not production ready yet because of these reasons, basically. And so we have a pretty big to-do list. The first one, we are limited to very specific Erlang and Elixir versions. That's because of our standard library tweaking thing. However, I think we can drop these limitations pretty easily already as we improve the AtomVM, and we don't have to do that much tweaking. Also, the stability of AtomVM itself needs a little bit of improvements because we can crash the VM from time to time. There are some missing features that we keep discovering. And unlike Davide said, our approach doesn't show you what works and what doesn't. You have to try it and check. Also, because our target is to basically support everything. Also, we need to improve performance. Like, it works reasonably fast, I would say. However, some things are taking a long time. For example, compiling a bit more complex modules takes a lot of time, and we need to figure out why and find these bottlenecks and fix them. Another thing is that I mentioned that AtomVM is 190 kilobytes. However, the problem is you also need to load the code and load the standard library. And the standard library is over 3 megabytes when you gzip it. So for some use cases, it's acceptable. For many use cases, it's too much. So what we need to do is we need to only ship the code that is actually needed by the particular project. For IEX, there will be the whole standard library, but for the game of life, a demo, or any other project that doesn't involve compiling the code, it's a very small subset, I would say. So we can improve that a lot by detecting what is actually used. So the last thing is, the last big thing is the support for WASI. So WASI is basically about running WebAssembly on the server. So that basically we could have a sandbox Elixir running on the server on AtomVM, which would be pretty cool. But you cannot compile AtomVM to WASI just yet. We have to figure out how to do that and how much work it is. So as you can see, it's quite a lot to do still. However, I'm sure that if you go, try it, break it, submit issues, submit PRs, that would be lovely. then we can make it stable in a reasonable time. And we can have Elixir running in the browser in a production scenarios, in a production use cases. So that's pretty much all I have for today. So thank you all. And we are happy to take any questions.
All right, are there any questions here? Yes.
You mentioned that in AtomVM, that nerves kind of solves a bit of a different problem. One thing that I liked about nerves is the firmware updates, how it does it. Do you see any overlap where we could like reuse that across both projects maybe and use that for AtomVM? Because that's something that would be very powerful, I think, right?
Yeah, we had some kind of discussion, and when we had it, it was still early because we were missing some bits, but things have changed a lot in previous month. So we are going to support software updates, so full OTA support, and so we can move forward to have some overlap. Also, I have planned to have some discussion with Nerve's team, and we would like to have a common API, something like behaves in the same way. So we want to replicate as much as possible Nerve's modules, so you can port back and forth from Raspberry Pi to ESP32 and vice versa your code. So that will be great.
We have a couple online questions. How many people are working on this project?
So on the software management side is now 4 people, and on the AtomVM side is definitely Paul and Davide, and I'm not sure if anyone else.
We have other contributors. Some are more active, some other less. I mean, we accept any kind of contribution, or even casual contributions, just a few lines of code or even typos. We like all kinds of contributions.
Could it be embedded in, for example, Explora or XLA to avoid going from native code to Elixir with custom functions? Does that make sense?
I don't understand that.
Okay, I am missing the context of this question, but if anyone wants to reach me or Mateusz, we are really glad to answer to these questions.
Okay. Yeah. Does AtomVM support real-time capabilities?
We don't support yet those stuff. Yeah, we are talking about embedded stuff. We are also moving to hardening the whole stuff, making sure that you can limit resources of what a process can do. There are some POCs around, but still it's something more advanced that it will arrive eventually.
Okay, thanks. Any other questions? You're going to have to raise your hand or speak up. No? Well, hey, appreciate the great job, and thank you very much. Let's give him a big round of applause.
Thank you.